We are going to take a trip down memory lane for a chapter 1 review. Still with me, Miss Bowman. These are factor puzzle. If we remember correctly, we look for the numbers that go into both of them. So between 12 and 21, 3 is a factor. I write that. Something times 3 equals 12. That's 4. I bring it across. Something times 4 equals 20. That's 5. I bring that down. Something times 3 equals 21. 7. Bring it across. 7 times 5 equals 35. Remember, I'm looking at factors. It's like looking at the rows and columns on a multiplication table. This time I'm going to look at each side of the rate table and see if they go up. So for 1 minute, this person goes 5 miles. Maybe it's in a car. So I know that 5 times 1 would equal 5. 5 times 5 would equal 25. That checks off. 7 times 5, because for each minute I go 5 miles, so I multiply the minutes by 5 and I should be able to check that off. 7 times 5 checked out to be 35, and 7 times 5 is 45. You see I accidentally write 35, but I see that it's 45 on the right. So yes, this is a rate table. It's just kind of mixed because the minutes don't go in order, but it still is a rate table because the unit rate is 5 miles per minute. I can multiply the minutes by 5 and still get the correct number. We'll move on to number 10. I can look at those and I see that it's 5 miles per minute. Okay, yep, okay, 2 times 5 is 10. 3 times 5, what? No, 3 times 5 would equal 15. So I have to make sure it multiplies by 5 because that's my miles per minute. 5 times 5 equals 25. I can just stop right there knowing that this is not a rate table because the unit rate is not constant. Remember, those minutes can go out of order, but as long as they're a multiple of 5 in the miles, it works. But in this case, it does not. We'll look at number 11. In this one, I have to fill in the rate table, so I have to complete it and I have to graph it. So for 1 pound, there's blank number of dollars. And I know in my pounds, it goes up by 1. So 1, 2, 3, 4, 5. From 12 to 15, it went up 3. So I know 3 is my rate. So I can actually count by 3, 6, 9, 12, 15, and fill in the other side for dollars. My unit rate is $3 per pound. I mean, I could write it 1 pound per $3, but it just sounds better in general, writing $3 per pound. When I graph it, I have to label my sides. So I label one side pounds and one side dollars. I will not be doing the entire rate table just for time, but I will be showing you how to start it. So I go over 1 for pounds and up for $3. I go over 2 for pounds and up to 6 that time. Remember, my pounds is on my X, my dollars is on my Y. Those are the axis. So when I go over to 2, it goes up to 6. When I go to 3, it goes up to 9. If I went up to 4, it'd go up to 12, and 5 would go up to 15. I'm still using my same rate, but I'm graphing it. And when this asks to show the unit rate triangle on your graph, I make a triangle from point A to point B, and it's right there. Now we'll move on to number 15. This time I need to complete the ratio table. This is interesting because I actually have to fill in some clues. Now I know to go from 6 to 9, I have to go up 3. And from 12 to 16, I have to go up 4. So I know 3 and 4 are going to be my main numbers I'm looking at. So for 3 roses, I have 4 daisies, and I fill that in. So it's a 3 to 4 ratio. Same thing here. To go from 5 to 10, I go up 5. And on the other side, from 14 to 21, I go up 7. So my rate is 5 to 7, or my ratio is 5 to 7. So in the blue circles, I'll put 5 and 7. So the apples should go 5, 10, 15, 20. And the oranges go 7, 14, 21, 28. Again, this should be a review from chapter 1. For these proportions, I always go back to our friend, the factor puzzle. Hopefully I am able to figure out that I need to move this down so you can see it. I fill it in, keeping my numbers in order. So 4 to 9, oh, there we go, is equal to 12 to A. Now I don't necessarily put an A, but I do leave it blank. And I line up my 4 and my 12 because those numbers go together. It's just like if I did roses versus daisies, I would keep my roses in order, my daisies in order. I solved this through a factor puzzle, and I ended up getting A would be 27. When I do this for B to 10, 12 to 15, I leave my B blank. I could write a B in there and just erase it. And I go through the steps for my factor puzzle. 10 and 15, they share a factor of 5. 5 times 3 is 15, carry it across. 3 times something, 4 is 12. And I follow through my steps, and B equals 8. For number 19, we're looking at basic ratio, so I'm taking it down as low as it can go. This should be similar to what we've learned with fractions in a review from 5th grade. I'm actually going to write it in fraction form, and I know that the biggest factor that 12 and 20 share is 4. 4 goes into 12 3 times, 4 goes into 25 times. That is the absolute lowest it can go. So my final factor ratio is 3 to 5. So let's look below. Just upon first look, I know I'm going up by 7s on one side. So 7, 14, 21, 28, 35. So those are all factors of 7. If I go to the right column, 6 to 12 is 6, 12 to 24 is 12, 24 to 30 is actually 16. I think I wrote 12 on here. So that's not going up at a constant rate. It's kind of all over the place. So no, this table is not a ratio table because the left column shows a constant increase, but the right does not. Remember, if this was a true ratio table, they would both be going up by, the left by 7, the right by 6. That would be completely fine because it's going up with the same ratio every time. So, for every 2 cookies, I have 1 push-up. So 4 cookies, 2 push-ups, 6 cookies, 3. So that kind of thing. Like they're going at separate numbers, but they're going up at the same rate. I know it's confusing and it's kind of weird to think back all the way to chapter 1, but it's always good to review. When we're done with this, we'll be going to problem solving. In this, I personally like to use a lot of factor puzzles, but I will show you different ways how to solve it. So, number 21. Tomatoes cost $2 per pound. What is the cost of 6 pounds of tomatoes? And again, I know I should move this down. I need a better arm, I guess, for my iPhone. I like to draw it out for 6 pounds of tomatoes. So there's each square equals 1 pound. And it's $2 or $2. So 2, 4, 6, 8, 10, 12. I could also think if it's $2 per pound, 6 pounds of tomatoes, 2 multiplied by 6, if I wanted to do it that way. Melinda rides her bike at a constant speed. If she rides 8 miles in 2 hours, how far will she ride in 3 hours? I make a factor puzzle. So my first row would be 18 and 2 because it's miles and hours. My next one would be blank for the miles and 3 for the hours. And I would go through and solve it this way. So between 2 and 3, the common factor is 1. 1 multiplied by something is 2. And 2 times 9 is 18. Bring my 9 down. I do the same thing with the bottom. And I would fill in for miles, it'd be 27. It's always a good idea to use a factor puzzle when you feel comfortable with using this as a mathematical tool to help solve. Abby saves $3 per week, and Louise saves $8 per week. How much will Abby have saved when Louise has saved $72? So I could make a factor puzzle. I'm going to make a table, and you'll actually see, because I write really large, my factor puzzle will have like part 1 and part 2, but I will fill this in with Abby's 3, 6, 9, 12, 15. It's going up by 3s because she saves $3 per week. Louise, on the other hand, will go up by 8s. So I have 8, 16, 24, 32, and 40. Now I will have to make another part of this table. I can't help it that I write really large. So there's part A and part B, or 1 and 2, either way. And I will continue with Abby and Louise and tracking their money. So Abby would continue with 18, 20, 24, 27, and Louise would go from 40 to 48 to 56 to 64 to 72. And I know 72 I can just stop at because that's what the problem says. They just want to know how much will Abby have saved when Louise has $72. So I fill in Abby's and I get a final answer of 27. You can totally see that Louise is saving way more money than she is, even though they've saved for the same amount of time. The fact that he's saving $8 per week is really going crazy. So Greg mixes 6 cans of black paint with 8 cans of white paint to get gray paint. How many cans of black paint will he need to mix with 48 cans of white paint to get the same color? I solve it with a factor puzzle. My 6 for the black paint to the 8 for the white. I leave the square under black blank, and I put the 48 for white. So between 8 and 48, they share a factor of 8. 8 times something equals 8. It's 1. Put my 1 all the way across, and 6 would go on top. 8 times something equals 48, which is 6. And I would carry my 6 to the left, and I would have an answer of 36 because 6 times 6 equals 36. So Greg would need 36 cans of black paint. And for the extended response, number 25, write and solve a proportion word problem for this proportion. 6 to 10 is equal to 21 to D. So I will use my 2 favorite characters, myself and Mrs. Smith, and we're going to be saving pencils. So Miss Billman and Mrs. Smith save pencils at the same rate weekly. Miss Billman saves 6 while Mrs. Smith saves 10. How many pencils does Mrs. Smith have when Miss Billman has 21? I would make a factor puzzle for this. This is the greatest way to do this because you can keep all your numbers in order, and I don't have to, start counting on my fingers and toes and, my eyelashes as to how many is this. I also don't have to feel like I'm doing anything wrong when I feel really comfortable with a factor puzzle. And side note, kind of depressing, how bad my handwriting looks in this. I normally like to think I have good handwriting, but for some odd reason, it looks super janky in this. So I'll have to work on that for the next video. When I make this factor puzzle, I line up my numbers, 6 and to the right, 10, and the 21 would go under the 6 because those line up. Those are my pencils. And the 10 would have a blank square underneath it. That would be the D for how many pencils Mrs. Smith has saved, because we're wanting to save the pencils for all the students. So when I do this, I look at 6 and 10. What number did they share? Or I could even start with 6 and 21. I know they share 3. So 7 times 3 is 21. 3 times something is 6. It's 2. Carry it across. 2 times something is 10. 5. Bring it down is 35. So my final answer is 35. That was a super quick chapter 1 review. Thanks.